All right, so here we go, part B. So now what is happening, part B. What's happening is as that camera watches the rocket go up, there's another thing that is changing with respect to time, which is theta.
I think I care. CNN be more respectful of other people's job descriptions.
But I thought we didn't need this anymore, so.
So now, theta is a function of time, and that's what we're trying to find here. How fast is the camera's angle of elevation? So we are trying to find d theta over dt. How fast is it going, changing up? This could be important because if they know exactly how fast the rocket's going to be going up, they could have the camera on a mechanism so that it is rotating just perfectly rather than having someone who's shaking take the video all the way up, right? So, because they're so excited. It's a rocket. Okay? We still know that y is a function of time, and we still know that dy dt is equal to 600 feet per second. This is where the question becomes, how do we write an equation that has theta and y? We know sine and cos and tan. So which one of those would be the easiest way with the information that we have? Sine would involve the opposite and the hypotenuse, but then we would have to include the z that we figured out from part A, which will work and could work. But if we use tan, then we can just use the y and the 4,000. So we got tan of theta is opposite over adjacent. Well, we want to figure it out at y equals 300. Hmm? This will be same as the last one would be calculator, right? We could also do it with z, and we figured z out from prior, right? We know that it's 5,000, and we figured out that it was 360 feet per second. So we could do it with that as well. That'll just make the... Yeah, this one's going to be nicer because this is a number that doesn't change. So when we take the derivative with respect to time with the tan function, we won't have to use a quotient rule. Whereas if we used y and z with sine, then we'd have to use the quotient rule, and it would just be more numbers to plug in. Should give us the same answer, though. So this will be better. Now, we need to take the derivative of this with respect to time. What's the derivative of tan?
Negative cosecant.
Squared.
Nope.
Cosecant squared.
Secant squared.
Wait.
Secant squared. Yay. So secant squared. So for your quiz tomorrow, make sure you know all the derivatives of sine, cos, tan, secant. Okay. Secant squared theta is the derivative of tan. Then it's a chain rule. What's the derivative of theta? D theta dt equals 1 over 4,000 times dy dt. Well, this is like 1 over 4,000 times y, and the derivative of any constant, like if I had just had 3y, the derivative would be 3. If I had 5y, the derivative would be 5. So I have 1 4,000th y, so the derivative is 1 4,000th. Yeah, today's lesson is brought to you by Sweet Tarts, contributed by Caitlin International.
They're so cheap in the States. They're like $1.50, totally worth it. I brought back like 8 packs of them.
8 packs. Nice. Okay, so in order to figure this out, we wanted to figure out when y was 3,000, right? Exactly when it has risen 3,000. But that does not tell us anything in the information here because, well, we know that we still have this is 600 feet per second. Is that right?
Yeah.
So we know that this is 600. We want to solve for d theta dt. But what is, maybe I'll even write this as 1 over cos squared. What is theta? It is an angle. Okay, here's our triangle again. We want to find out theta exactly at the point where this is still 4,000 because that never changes, but we're finding it out exactly at the point where that's 3,000. Could we figure out theta?
300. 3,000 divided by 400.
So tan inverse of 3,000 divided by 4,000.
But we just had done that in general at the beginning.
Well, this is just going to tell us, and I'm going to use radians because we're in higher level math, so. Ooh. And we get that theta at that point is 0.6435. Of course, I'll store all of those decimal places into my calculator. And then I'm going to have 1 over cos squared of theta. So d theta dt would equal 600 over 4,000 times by cos squared of 0.6435. And all right, d theta dt, my calculator says 0.096 radians per second.
That was the right answer.
That was the right answer from before? There's the happy dance again.
Happy dance is kind of scary.
Yeah.